In this video, we are going to review number 5 and 6. Okay, number 5. First thing we're going to want to do is condense this. You notice there's addition, so we're going to use our product property. We will get log x times x minus 3 equals 1. From here, we're going to put this in exponential form. My base, it's a common log, so my base is 10. 10 to the first power equals the argument, which is x times x minus 3. And now let's clean this up. I've got 10 equals x times x, x squared. That is a negative 3x. Let's set this equal to 0 so we can solve. We'll subtract 10 from both sides. X squared minus 3x minus 10. Okay, we can factor this. I'm going to set up my binomial. Okay, two numbers, when I multiply them I get negative 10. I add them I get negative 3. There's a negative 5 and a positive 2. Using my zero product property, I get x equals 5 and x equals negative 2. Let's check these solutions. Let's do x equals 5 first. So we would have, I'm just going to plug this into the original equation, log 5 plus log 5 minus 3, does it equal 1? I get log 5 plus log 2 equals 1. Here I'm going to condense. Product property, 5 times 2 equals 1. That is log 10 equals 1. Let's write this in as an exponential just to double check and make sure this is good. My base, it's common log. My base is 10. My exponent is 1. The argument is 10. This is a true statement. So I know x equals 5 is in fact a solution. Now let's check. What do we got? X equals negative 2. Let's plug it in. Log. Right here, I'm already seeing something is not kosher. We have a negative number here. We're going to have a negative 5 here. Negative numbers are not in the domain of logarithms, so this is not a solution. This is not in domain. Number 6. Okay, first thing I want to do, I'm going to condense. I have subtraction, which means I'm going to use my quotient rule. Natural log of x minus 3 equals the natural log of, my numerator is 7x minus 23. My denominator will be x plus 1. Okay, now your one-to-one property of logarithms states if you have same basis, your arguments are going to be equal. So that means I have x minus 3 equals 7x minus 23 all over x plus 1. Start cleaning this up. I'm going to multiply both sides by x plus 1 to clear the denominator. Equals 7x minus 23. Okay, and now let's start distributing. I get x squared. Let's see, that's a negative 3x plus 1 is a negative 2x minus 3 equals 7x minus 23. And let's move everything over to the left side of the equal sign so we can have this set equal to 0. X squared, negative 2x minus 7x, negative 9x. Negative 3 plus 20, plus 23 is going to be is positive 20, excuse me. Let's factor. Two numbers, when I multiply them, I get positive 20, but add them, I get negative 9. That would be a negative 5 and a negative 4. Using the zero product property, I get x equals 5 and x equals 4. Let's check them. Check x equals 5. Okay, so that would be natural log. I'm just plugging this back into the original. 5 minus 3, does it equal the natural log of, let me make that a bracket, 7 times 5 minus 23 minus, I'm running out of lead, minus natural log of 5 plus 1. Clean it up. Natural log of 2, does it equal natural log 35 minus 23, that would be 12, minus the natural log of 6. Let's condense this. Natural log of 2, natural log of 12 over 6. 12 over 6 is 2. These are equivalent. Let's check the next one. X equals 4. Okay, plug it in. Natural log of 4 minus 3, does it equal the natural log of 7 times 4 minus 23 minus the natural log of 4 plus 1? Natural log of 1 equals natural log 7 times 4, 28 minus 23, 5 minus the natural log of 5. If we go ahead and do the quotient property, natural log of 1 equals the natural log of 5 over 5, which 5 over 5 is 1. This one also checks out. Therefore, x equals 5 and x equals 4 are both solutions.